In the endless night of space, Peggy Whitson, the woman who has traveled farther than any human in history, looked deep into the silence where light itself was still being born. There she saw not just stars, but the very breath of the universe, the quiet heartbeat of time unfolding in front of her. The data she brought back was not mere numbers. It was the whisper of creation's first memory. Perhaps when we gaze long enough into the cosmos begins to gaze back at us. If you wish to listen to the echoes of the stars, to feel the poetry hidden within science, then gently press like, subscribe, and leave your thoughts drifting in the dark below. For what comes next will take us to the origin of the cosmic crisis, where every law of physics begins to tremble. In the quiet fabric of the cosmos, something is stretching, breathing, moving away from itself. For more than a century, we have known that the universe is expanding. Yet now the very act of that expansion is turning against the logic we built to understand it. Peggy Whitson once said during her long orbit around Earth, "The farther I look into the dark, the more I feel the universe looking back." Perhaps she was not speaking only of wonder, but of the unease that comes when the cosmos refuses to behave as it should. Astronomers using the Hubble Space Telescope measured one rate of expansion, and theorists using the afterglow of the Big Bang, the cosmic microwave background, found another. Both methods are precise, both repeatable, both true within their own domains, and yet they contradict each other by a margin too large to dismiss. This is what scientists now call the Hubble tension, a quiet crisis at the heart of cosmology. Adam Rees, Nobel laureate and lead of the SH0ES project, admitted, "We have ruled out measurement error. What remains is something new, something wrong with our model of the universe." When such a mind speaks with hesitation, the world should listen. The Hubble constant is supposed to tell us how fast galaxies recede from each other with distance. But James Webb's ultra-precise data deepened the wound rather than healed it. Webb confirmed both sides. The near universe expands faster than it should. The distant universe expands more slowly. It is as if space itself breathes unevenly, one lung inhaling faster than the other. Some physicists compare it to a balloon that inflates unevenly, one hemisphere stretching while the other resists. Yet the laws of physics insist that cosmic expansion must be uniform. So if it is not our instruments at fault, what is tearing reality apart? Dark energy is the first suspect. That invisible pressure, making up 70% of all that exists. Perhaps it is not constant as we once thought. Perhaps it shifts like the tide, flowing differently in distant regions of the universe. Dr. Priyamvada Natarajan of Yale once mused, "Maybe dark energy is not the stage on which the play unfolds, but a character that evolves with it." If true, the cosmos may not simply be expanding, it may be evolving in mood and rhythm. Others propose new particles or hidden forces influencing gravity on immense scales. Unseen hands shaping the flow of time itself. One radical idea suggests that our corner of the universe is moving through a vast underdense region, a cosmic bubble causing our measurements to differ from the cosmic average. Avi Loeb from Harvard framed it simply, "If the numbers don't agree, maybe the universe is trying to tell us that we've misunderstood what it is." To grasp this paradox is to stand at the edge of knowledge itself. scientists stare into the data like sailors at the horizon, knowing that beyond this curve lies uncharted sea. The tension between Hubble and Webb is not a failure of science. It is science doing what it does best, finding the limits of what we know. Imagine the universe as a vast breathing organism. Every galaxy a cell. Every cluster a pulse of its ancient heart. For billions of years that heartbeat has been steady. Now it trembles. Could it be that cosmic time itself flows at different rates in different places? That the great clock of the universe has more than one hand? To those who stare through telescopes night after night, this mystery is not despair, but invitation. The unknown is where imagination lives. Peggy Whitson once recalled looking out the window of the International Space Station, the Earth turning silently below, and she whispered, "Out there, every question becomes a prayer." So what do we learn from this cosmic contradiction? First, that humility is the foundation of discovery. When the universe refuses to fit our equations, it is not mocking us, it is teaching us. Second, that beauty and mystery are not separate from science. They are its essence. As viewers, listeners, wanderers under the same night sky, we too are part of this story. The same dark energy that pushes galaxies apart flows through every atom in our bodies. The same expansion that stretches the cosmos also stretches time between our heartbeats. Perhaps that is why this paradox feels personal. When we speak of two speeds of expansion, we are also speaking of the human condition, our minds racing ahead while our hearts linger in the past. The universe expands at two rates because we do too. One for reason, one for wonder. The Peggy Whitson space discovery story reminds us that exploration is not just outward but inward. Every deep space exploration is also a search for meaning. Every cosmic mystery explained is a mirror held up to the mystery within. The James Webb Universe Crisis does not destroy science, it renews it, forcing us to reimagine what laws truly govern a living universe. As we move toward the origin of the cosmic crisis, let us listen not just to data but to the silence between the numbers. For in that silence lives the heartbeat of creation itself. When you gaze into the sky tonight, remember this: every star you see is moving away from you. Yet their light still reaches your eyes. The universe expands, but connection remains. Like the scientists who question and the explorers who dare, we too must keep looking, keep wondering, keep listening to the quiet music of the cosmos. Because perhaps the greatest discovery of all is not what lies out there, but what awakens within us when we finally learn to see. In the young breath of the universe, when time itself was still soft and light had only begun to wander, something impossible appeared. 6 galaxies, massive, luminous, mature, shining like full-grown giants in a cosmos that was supposed to be a newborn. They have been called the universe breakers, and rightly so. For their very existence breaks the spine of everything we thought we knew about how galaxies are born. When James Webb turned its golden eyes toward a quiet patch of sky near the Big Dipper, astronomers expected to find faint wisps of light from baby galaxies still stumbling through their first billion years. Instead, they found titans, each one filled with billions of stars, each one burning with maturity far too early in cosmic time. Erica Nelson, the astrophysicist who first spotted them, whispered, It's like finding fully ripe, grown trees in a garden that was planted yesterday. The problem is not small. It is catastrophic for theory. In our models, gravity works slowly. Clouds of hydrogen and helium coalesce. Stars ignite. Galaxies merge and evolve over billions of years. Yet here we see enormous systems thriving when the universe was just 3% of its current age. How could so much matter gather so quickly? Unless the invisible scaffolding of dark matter pulled it together with unimagined speed. Dark matter is the silent architect of structure, shaping galaxies without ever shining itself. For decades, we thought we understood its pace. Slow, patient, obedient to gravity's rules. But these early giants whisper another story. A story of acceleration, of dark matter collapsing in storms of creation. If this is true, our entire picture of cosmic evolution must be rewritten. Galaxies did not crawl into being, they bloomed in a cosmic instant. The Peggy Whitson space discovery narrative reminds us that even human exploration mirrors this paradox. We expect progress to be slow. Yet sometimes knowledge leaps forward in a single heartbeat. When Peggy looked through the porthole of the International Space Station, she once said, "Out there, growth is not measured in time but in wonder." Perhaps the same is true for galaxies. Perhaps the early universe was a crucible of impossible wonder, where matter learned to dance before learning to crawl. Yet even the universe breakers were only the first shock. Because not far from them, James Webb saw something lonelier and more haunting, a black hole without a home. A supermassive singularity, drifting naked through the dark. Astronomers call it Cuson, a name that sounds like a song from another world. In every galaxy we know, black holes sit at the pice, center like hearts, binding billions of stars through their gravity. But Cuson has no such host. It floats alone, immense yet solitary. Containing the mass of 50 million suns compressed into a space smaller than our solar system, it should not exist where no stars have lived or died. Dr. Roberto Maiolino from Cambridge called it a cosmic orphan that should not be alive. His words carry both awe and disbelief. Because to find such an object so early in the universe means that black holes might not be the children of stars at all, but their ancestors. If Cuson is what some suspect, a primordial black hole, born in the first seconds after the Big Bang, then it predates light itself. Imagine that. A creature of gravity forming before the first atoms, before the first spark of fusion. A silent vortex waiting for a universe to grow around it. It is as if the cosmos planted its own seeds of darkness before it allowed stars to bloom. Andrea Ferrara, the Italian cosmologist, once said, "If black holes came first, then everything we see may have grown from their shadows." That sentence lingers like an echo of creation. For if true, then we owe our galaxies not to light, but to the gravitational hunger of these ancient voids. Between these two discoveries, the 6 impossible galaxies and the naked black hole, lies a deeper question. Have we misunderstood what time means on a cosmic scale? Perhaps early epochs were not slow at all. Perhaps the fabric of space-time itself pulsed faster, compressing billions of years of formation into cosmic moments. The deep space exploration of this paradox shows how far humanity has come, and how far we have yet to go. James Webb's gaze does not just reveal new worlds. It reveals our own ignorance, illuminated in infrared, When I look at the universe, breakers and Q-son, I feel both terror and tenderness. Terror, for what they imply that our understanding of physics may be only a child's drawing on the wall of eternity. And tenderness, because they remind us that discovery begins with humility. As a scientist, I am trained to seek answers. But as a human being, I cannot ignore the poetry of what these findings whisper. The universe is not just expanding, it is remembering itself, creating echoes of beginnings we were never meant to witness. This is why the Cosmic Mystery Explained series is not just science, it is meditation. When we speak of galaxies forming too soon, we are also speaking of the parts of ourselves that awaken too early, of dreams that outgrow the time meant for them. So, what do these impossible objects teach us? They teach that reality is flexible, that truth can stretch without breaking, and that wonder is not a symptom of ignorance, but its cure. The James Webb Universe Crisis has become a mirror held up to our collective understanding, showing us that every answer breeds a deeper question. These discoveries are not the end of knowledge. They are the start of a new language of the cosmos, one written in infrared light and silence. Peggy Whitson once reflected, "Out there, science and spirit are the same thing, they both ask us to keep looking." Perhaps that is the true lesson of these cosmic anomalies, to keep looking even when what we see shouldn't exist. Because the universe often hides its deepest truths in the places where logic begins to fail. And so we drift with James Webb through the velvet dark, following the trail of light from galaxies too old to be young, chasing a black hole that should not be alone. Each discovery stretches the mind. Each mystery opens the heart. Maybe in the end, the greatest revelation is not that the universe breaks its own rules, but that it invites us to do the same, to step beyond certainty, to let awe become our compass. For every universe breaker out there is a question waiting within us. And every Q-son drifting in the dark is a reminder that even the loneliest void can become the seed of creation. This is the origin of the cosmic crisis. Not a failure of understanding, but a rebirth of curiosity. A moment where the universe whispers once more, look deeper. Always deeper, because the impossible is only the beginning. In the beginning, there was no light, only pressure, gravity, and the slow heartbeat of a universe learning how to exist. Long before stars began to shine, long before galaxies spun their silver arms through the dark, there may have been black holes, silent vortices shaping the newborn cosmos. We call them primordial black holes. Ancient ghosts born in the first seconds after the Big Bang, when the universe was still a storm of energy and chaos. Density fluctuations twisted spacetime upon itself, and some regions became so heavy that they collapsed instantly into gravity's own shadow. Stephen Hawking once said, "Black holes are not the end of the universe, but its most poetic beginning." Those words feel truer now than ever, because new evidence from the James Webb Space Telescope hints that black holes might have appeared before the first stars were even born. If that is true, then we have misunderstood the hierarchy of creation. We thought that stars came first and black holes followed as their tombstones. But perhaps it was the other way around, that black holes were the architects of light itself. Imagine the early cosmos as a vast ocean of hydrogen and helium, still cooling from the violence of birth. In this ocean floated tiny whirlpools of gravity, primordial black holes, each one gathering matter around it like dust around a flame. As gas spiraled inward, it heated to millions of degrees, glowing with X-rays and ultraviolet light. In that glow, the universe found its dawn. Light, not from stars, but from darkness. Andrea Ferrara from Scuola Normale Superiore in Pisa once described this possibility as a cosmic irony so beautiful it hurts the first light born from the deepest darkness. For centuries, we have defined light as the opposite of shadow. Yet here they seem to be parent and child, inseparable in the story of creation. If primordial black holes existed, they did more than shine. They sculpted the universe's first architecture. Their immense gravity acted as scaffolding, drawing gas and dark matter into the filaments and nodes that would one day become galaxies. In this way, black holes may have written the blueprint of structure itself. The cosmic web we see today may have been woven by their invisible hands. And yet the universe did not stop inventing new ways to defy our understanding. For James Webb has revealed another kind of creation, black holes that do not wait for stars to die, but are born directly from the collapse of immense clouds of gas. Scientists call this the direct collapse mechanism, a process so violent and so pure it bypasses the entire life cycle of stellar evolution. Peter van Dokkum from Yale explained it simply. It's like watching a mountain fall into itself before it ever becomes stone. These direct collapse black holes form when vast rivers of primordial hydrogen flow together between merging galaxies. Their gravity so intense that they skip every intermediate step, collapsing straight into black holes millions of times the mass of the Sun. They do not wait for supernovae. They do not evolve. They are born already ancient. What does this mean for us? For cosmology? For everything we thought we knew about creation? It means the early universe was far more violent and creative than we ever imagined. A place where chaos was not the enemy of order, but its mother. Where destruction and birth were the same breath. In every photograph from the Peggy Whitson Space Discovery Archive, you can sense that same paradox. The beauty of fragility held within immense force. Peggy once said from orbit, "Out here, silence is not empty, it's full of creation still happening." The same could be said of these black holes. Silence that creates. Gravity that gives form to light. As a scientist, I find myself humbled before this idea, because it means that everything we are, our atoms, our stars, our galaxies may have grown around, invisible anchors born in the first instant of time. We are literally shaped by darkness, sustained by what we cannot see, and enlightened by what we cannot understand. The deep space exploration of these mysteries is not only a journey outward, but inward, toward a recognition that knowledge itself is a form of faith. We trust in equations, in photons, in signals that traveled billions of years to reach us. Yet behind every number there is a whisper of wonder saying this too may change. Neil deGrasse Tyson once remarked, "The universe is under no obligation to make sense to you." The James Webb Universe Crisis reminds us that confusion is not failure. It is evidence that we are still alive in the adventure of knowing. Perhaps the greatest lesson of primordial and direct collapse black holes is that beginnings are never clean. The first light was born not in calm but in collapse, in tension, in the surrender of structure to gravity's will. There is something deeply human in that. For our own moments of clarity often arise from falling apart. The cosmic mystery explained through these findings is not simply that black holes came before stars, but that creation itself prefers paradox. That the universe is built not upon certainty but on contradiction, beautifully resolved through time. When I contemplate the origin of the cosmic crisis, this realization that our most stable truths can vanish overnight, I feel both reverence and relief. Reverence for a cosmos so rich that it defies definition, and relief in knowing that discovery will never end. Maybe that is the true nature of the black hole, not a void but a promise. That within every collapse lies the potential for new understanding. As you listen to this voice drift through the quiet between stars, imagine those ancient black holes still, glowing in the far reaches of time. Their gravity pulling us not into darkness but into awareness. Because perhaps the universe itself is whispering a simple truth: to see the light, we must first learn to love the dark. Out there in the cold between stars, where sunlight fades into silence, wander worlds that should not exist. Astronomers call them jumbos, giant rogue planets drifting freely through the dark. Yet something extraordinary has happened. They travel not alone but in pairs. Two wanderers bound by gravity, sharing warmth in a universe that offers none. It is a tender image, and yet a scientific enigma. How can hundreds of these planetary pairs exist without the guiding hand of a parent star? What law of formation could have allowed such companionship to survive the chaos of cosmic birth? Dr. Nuria Miret-Roig from the University of Bordeaux said it best. Finding twin planets in dark, interstellar space is like finding two candles still burning in a hurricane. Their shared orbit defies the violence of their origins, suggesting that gravity and memory may be stronger than chaos itself. Even more mysterious, these jumbos emit radio signals bursts stronger than those of many stars, swirling with magnetic storms and auroras that pulse like cosmic heartbeats. Are these purely natural phenomena, or could they be signatures of technology far beyond our understanding? Peggy Whitson once reflected while orbiting Earth. Every signal in space feels like a whisper from something waiting to be known. Perhaps that is what these rogue pairs represent. Whispers from a time when planets were not yet loyal to stars. Free souls drifting through eternity. Yet not all discoveries bring comfort. For James Webb also revealed a place that seems to strip the hope of water itself, a protoplanetary disk, known as XUE-10. A system where planets like Earth should be forming. Yet the telescopes find no trace of steam. No whisper of H2O. Only the harsh breath of carbon dioxide. In this dry nursery of worlds, we are forced to confront a sobering thought. Perhaps water, the elixir we take for granted, is not the rule of the universe but its exception. Dr. Giulia Perotti of the Max Planck Institute remarked, "Finding a planet-forming disk without water is like finding a cradle without a heartbeat. If most planetary systems are born this way, then oceans like ours may be rare miracles, and Earth itself an oasis carved from improbability." It reminds us that deep space exploration is not only a quest for discovery, but for perspective. We search for other worlds, and in doing so realize how fragile our own truly is. Then there is the fiery enigma called 55 Cancri e, a planet so close to its star that its surface glows brighter than molten steel. Its temperature reaches 4,000 degrees Fahrenheit, And yet somehow, it has an atmosphere. The winds there move faster than sound, carrying metal vapor from its blazing day side to its eternal night, where the vapor condenses and falls back as rain made of titanium and silicates. Niku Madhusudhan from Cambridge said, "It is not a world, it is a furnace wrapped in a storm. But even in that storm, we find resilience. For the atmosphere of 55 Cancri may be reborn again and again from the planet's molten core. A cycle of destruction that endlessly recreates itself, much like the universe itself does. From there our gaze drifts to a darker wanderer, Simp 0136, a lonely planet without a sun, a failed star or a successful planet depending on how you look at it. It floats through space like a warm ember in an infinite sea, surrounded by clouds of magnesium and iron rain. Its magnetic field is so strong that it glows with auroras brighter than Jupiter's, shimmering ribbons of light dancing without any starlight to feed them. Dr. Melody Kao, who led its discovery, said, "This object teaches us that darkness is not absence. It can be its own kind of fire." In that sentence lies the essence of the Cosmic Mystery Explained series. Because each of these worlds, Jumbos, Shu 10, 55 Cancri E, and Simp 0136, challenges our quiet assumptions about what life and order mean in the cosmos. They remind us that reality is vast enough to hold both the beautiful and the unbearable, both the cold and the burning. As a scientist, I see data, wavelengths, spectra. But as a human being, I see mirrors of our own nature. We too are wanderers bound by invisible forces, sometimes in pairs, sometimes alone. We too live between heat and cold, between dryness and flood, between the yearning for light and the fear of it. The James Webb Universe Crisis is not merely a challenge to our equations. It is an invitation to humility, a reminder that the cosmos has never promised to be simple. Peggy Whitson once said from the window of the ISS, "When you look long enough into space, you start to see the universe looking back with patience." That patience is what science demands of us, and what wonder rewards. Perhaps the true origin of the cosmic crisis is not the chaos we find in distant planets, but the realization that even chaos has its own form of harmony. For every rogue world that wanders, there is another waiting to share its orbit. For every dry disk devoid of water, there is one blue sphere brimming with it. For every furnace world that burns, there is a silent ember that glows, alone in the dark. These worlds are not mistakes in creation, they are its poems. Verses written in fire and iron, teaching us that existence itself is a spectrum between extremes. So when you gaze at the stars tonight, remember that somewhere out there 2 rogue planets are holding on to each other. A sunless world is raining iron, and a planet made of lava is breathing its own atmosphere anew. The universe is not cold, it is simply patient, waiting for us to understand that every impossibility is another kind of beauty. And maybe that is the deepest lesson of all, that we are not here to conquer the unknown, but to fall in love with it. In the vast stillness between the stars, there drifts an ancient traveler named 3I, Atlas, a fragment of something older than the sun itself, a messenger from the dawn before our solar system was born. When James Webb and Earth's telescopes caught its pale green shimmer they were not just observing a comet. They were witnessing a relic of creation's first breath. This interstellar object is estimated to be more than 7 billion years old, which means it has seen stars live and die, galaxies merge and fade, and cosmic dust recycled into worlds uncounted. It has journeyed across the frozen rivers of the Milky Way for eons, untouched by time, until it crossed paths with us. Dr. Avi Loeb of Harvard once said, "Every visitor from beyond the solar system is a time capsule of another civilization of stars." 3I, Atlas, may indeed carry within it the chemical handwriting of suns that burned out long before our own came to life. Scientists studying its spectrum found something extraordinary. Its surface bears traces of crystalline silicates and heavy metals, materials forged in supernovae and ancient planetary cores. This means it may once have belonged to a fully formed world, shattered and cast into the interstellar dark when its parent system died. If so, 3I. Atlas is not just a comet, it is a fossil of a forgotten planet, a shard of history older than our skies. Peggy Whitson reflected on this idea during one of her missions. When you look down at Earth from orbit, you see how fragile it is. When you look out, you realize how ancient everything else must be. Her words echo the feeling that this small green wanderer brings a humbling awareness that our solar system is but a new ripple in an old ocean. But how could such a relic survive for so long, when radiation, collisions, and gravitational tides should have torn it apart? The answer may lie in its composition. 3I, Atlas, appears to be made of dense carbonaceous stone wrapped in layers of frozen gas, forming a natural shield against cosmic erosion. Some researchers propose that its dark surface is a kind of interstellar armor, a carbon mantle hardened by billions of years of exposure to cosmic rays. Others see in it a hint of the unknown, because 3I, Atlas, does not behave like any comet we've ever observed. It brightens when it should fade, accelerates when gravity alone cannot explain it, and moves with a composure that defies our models. Dr. Karen Meach from the University of Hawaii, who also studied Oumuamua, the first interstellar object ever found, remarked, "These things remind us that the universe is not a museum, it's alive, and it still surprises us." Indeed, if 3I Atlas can survive 7 billion years of exile, what else might be wandering unseen through the dark between stars? How many cosmic fossils are passing by us each century without notice? Some astronomers believe that interstellar visitors like this are not rare at all, but common. An unseen rain of alien stones falling through the galaxy, unnoticed because they are small, fast, and silent. It changes how we think about our place in the cosmos. For billions of years, the solar system may have been quietly intersecting with the debris fields of other suns, exchanging fragments like greetings across time. The deep space exploration of 3I, Atlas, is therefore not just about one comet. It is about the continuity of existence, the cosmic recycling that binds all worlds together. Every grain of dust on its surface is a survivor of events so ancient we have no language to describe them. When I look at the data from 3I, Atlas, I can almost imagine it whispering the story of its birth. Formed in the gravity well of a long-lost star, hurled into the dark when that system collapsed, spending billions of years wandering between suns, until, by chance, It brushed past ours. Such thoughts remind us of something profound. The universe does not forget. It stores memory not in words, but in matter, in stones that drift through eternity, carrying the fingerprints of everything that came before. Dr. Michelle Bannister said it beautifully. Interstellar objects are the letters of a galactic language. We just haven't learned to read them yet. As scientists, we are learning to listen, to trace meaning from their trajectories, to read the ancient alphabet of elements they carry. This is how cosmic mystery explained becomes not just a phrase but a mission, to recover the lost chapters of cosmic history etched into these wandering relics. The James Webb Universe Crisis has shown us that the universe is far more dynamic than our textbooks allow. And 3I, Atlas, is living proof. It is a messenger from a time when laws of physics might have behaved differently, when the temperature of creation still glowed beneath the fabric of reality. Perhaps these objects come not only to remind us of where we came from, but to ask whether we are ready to see the universe as it truly is: restless, connected, eternal. From a personal view, I find in 3I, Atlas, a lesson of patience. It has endured longer than any civilization, carried stories longer than language itself, and yet when it entered our sky, it glowed softly, asking for nothing but our curiosity. The origin of the cosmic crisis may not be about new physics or broken theories, but about rediscovering humility, realizing that we are newcomers in a universe filled with elders. Peggy Whitson once said, in a quiet interview after returning to Earth, "When you come home from space, you understand that every atom in you once belonged to a star." 3I, Atlas, is a reminder of that truth. We are not separate from the cosmos. We are its continuation. So as we gaze at this faint traveler drifting beyond Mars's orbit now, fading back into the black, let us remember that not all relics lie buried in stone. Some glide through infinity, carrying the memory of creation itself. Because in every ancient visitor like 3I, Atlas, the universe whispers once again, "I have been here before." In the deep red twilight of the early universe, James Webb saw something that no telescope before had ever glimpsed. 300 tiny points of light glowing crimson against the darkness, each one impossibly bright, impossibly old, and impossibly small. Astronomers call them the little red dots, but to many of us, they are more like cosmic riddles, enigmas written in the first language of creation. These objects should not exist. Not this early. Not this luminous. They shine from a time when the universe was barely a few 100 million years old. Yet, they blaze with the intensity of entire galaxies. Are they baby galaxies, newly formed and already bursting with stars? Or are they something stranger, black holes masquerading as galaxies? Dr. Joel Lager from Penn State University confessed, "It's like opening a history book and finding skyscrapers in the first chapter." These little red dots violate everything we thought we knew about the order of cosmic evolution. In our models, there should have been only faint ripples of light, tiny fragments of matter just beginning to coalesce. Yet Webb reveals blazing structures shining as if powered by engines beyond imagination. Some scientists believe they could be supermassive black holes accreting gas at the centers of forming galaxies. The first monsters awakening in the dawn of time. If so, then light itself, our oldest messenger, was born, not in the peaceful birth of stars, but in the violent hunger of darkness. Others argue that the little red dots may represent an entirely new class of object, something between a galaxy and a quasar, a phase of cosmic adolescence that our theories had never imagined. The Peggy Whitson Space Discovery Team described the emotion best. Every image from Webb feels like finding a hidden heartbeat in a fossil. And indeed, the little red dots are beating hearts, pulses of light from the earliest breath of the universe. To understand them is to ask how quickly the cosmos learned to create complexity. How could energy condense into such luminous order so soon after the Big Bang? Was there an unknown catalyst? A primordial turbulence accelerating formation itself? Perhaps these tiny red embers are the seeds of galaxies like our own, the ancestors of the spirals and clusters that now paint the night sky. Each one a whisper that says we were here first. And then there is the stranger tale of the infinity galaxy, a system so beautiful and paradoxical that it seems to break the laws of gravity and time itself. Discovered by Webb in the depths of the CER's field, it appears to be two galaxies colliding, yet somehow still holding their shape, like dancers touching in slow motion across 1 billion years. Between them glows a bright singularity, a point of light believed to be a newly born black hole, perhaps one of the first ever formed directly from collapsing clouds of gas. Dr. Erica Nelson called it a snapshot of the universe learning how to make black holes. In that collision, we may be seeing the direct collapse mechanism in action, where gravity wins without the need for stars to die, where gas itself gives up to the pull of its own weight. If so, the infinity galaxy is more than a structure. It is a memory of the moment when the cosmos learned how to vol. As a scientist, I find myself both exhilarated and unsettled by this image, because it shows that even in destruction there is elegance, that collision is not chaos, but choreography. The universe did not build itself gently. It shaped beauty from violence, harmony from collapse. This is what makes deep space exploration so humbling. We expect to find order, but the universe offers paradox, and in that paradox lies truth. The little red dots and the infinity galaxy are two faces of the same revelation. One shows us light blooming too early. The other shows us darkness being born from light. Together, they tell a single story that creation and destruction are not opposites, but twin currents of the same cosmic river. Dr. Priyamvada Natarajan once said, "Every time we look deeper, we see the universe breaking its own rules, and that's how we know we're on the right track." And perhaps that is the greatest truth these structures offer us, that progress in science is not about confirming what we believe, but about daring to be astonished. For those who follow the Cosmic Mystery Explained journey, the message is clear: there is no such thing as final knowledge, only deeper wonder, only more light waiting behind the next veil. Peggy Whitson once described floating above Earth and seeing lightning flash through clouds far below. It felt like watching the universe think. Perhaps these little red dots are the same brief flashes of cosmic thought from an intelligence larger than comprehension. In the context of the James Webb Universe Crisis, they remind us that we are living through a revolution of perception, that our instruments are not merely seeing farther, they are showing us that the past was never as simple as we imagined. From my own reflection, I feel a sense of calm, amid the confusion. Because the more the universe defies us, the more alive it feels. The little red dots burn like lanterns of curiosity, and the infinity galaxy arcs like a doorway to possibility. Perhaps the origin of the cosmic crisis is not a crisis at all, but an awakening. The moment humanity realizes that creation is still ongoing, that the universe is still inventing itself. And so we listen, quietly, as the night expands around us, knowing that somewhere beyond those crimson lights, infinity is still writing its story, one impossible structure at a time. When James Webb looked deep into the cosmic web, it found something so subtle, so profound, that it shook the very idea of stillness in the universe. Galaxies separated by millions of light years were spinning in the same direction, like dancers following an invisible rhythm. This discovery raised a haunting question. Is the universe itself rotating? Dr. Leo Shamier of Kansas State University remarked, "If galaxies share a preferred direction of rotation, then something in the early universe taught them to spin that way." It is a poetic thought, that even at its birth the universe might have carried a gentle twist, a memory of motion inherited from the moment of creation. We once imagined the Big Bang as a silent explosion of pure expansion, energy radiating equally in all directions. But what if that explosion also had spin? A cosmic momentum that still echoes through the orbits of galaxies today. If that is true, it could mean the universe behaves like a vast gyroscope, balancing motion across unimaginable distances. Some theorists have gone further, suggesting that we might live inside a rotating black hole, the interior of a parent cosmos whose spin gave birth to our own. Dr. Nikodem Popławski of the University of New Haven proposed this startling idea. What we call the Big Bang may have been the other side of a black hole, a white hole explosion inside a rotating parent universe. In that vision, every black hole becomes a womb for a new reality, each universe inheriting the spin of its creator, like cosmic DNA passed down through generations of existence. If galaxies turn together because of this ancient motion, then every spiral we see in the sky is a fossil of that first rotation. Every turning star, a memory of the day the cosmos began to move. To imagine this is to feel the universe not as a static geometry, but as a living whirlpool of time and matter. Dr. Brian Cox once said, "Motion is not chaos, it is memory made visible." And perhaps that is the truest explanation. The cosmic spin may not be random. It may be the first heartbeat of reality itself. But motion alone does not make a mind. For that we need connection. And James Webb has shown us that the universe is connected in ways far beyond our imagination. Across hundreds of millions of light years, faint threads of magnetism weave galaxies together, forming a structure so intricate that scientists call it the magnetic cosmic web. And when these filaments were mapped in detail, something extraordinary appeared. Their patterns mirrored the networks of neurons inside the human brain. Dr. Franco Vazza from the University of Bologna compared the two systems and found an astonishing parallel. The universe and the brain share the same degree of complexity and connectivity, despite being separated by 27 orders of magnitude in scale. It is as if the cosmos itself thinks, processing information not through synapses, but through gravity and magnetism, through the dance of light across invisible filaments. Each galaxy cluster becomes a thought. Each magnetic bridge a memory. Each wave of radiation a signal passing through the mind of the cosmos. Is this coincidence? Or design? Or simply the echo of the same mathematical laws shaping both neuron and nebula? If the universe organizes itself like a brain, then perhaps what we call life is not an exception, but a reflection, a local spark of a far greater intelligence woven into the fabric of space-time itself. Peggy Whitson once said after gazing down at Earth from orbit, "It's not just that we are part of the universe, it's that the universe is part of us." In the deep space exploration of these magnetic networks, we begin to glimpse what she meant. The same symmetry that shapes the cosmos shapes the mind that seeks to understand it. Perhaps consciousness is not confined to biology. Perhaps it is an emergent property of complexity itself, rising wherever connections grow dense enough to remember. The cosmic mystery explained here is not about where life begins, but where the boundary between matter and meaning disappears. When I look at these maps of the magnetic universe, I feel as though I am looking into the thoughts of creation. Lines of force and filaments stretching like neurons through the infinite night. If this is true, then every particle that moves, every photon that travels, participates in a grand conversation between energy and awareness. It would mean that when we study the cosmos, we are not just observing it from outside. We are listening to the mind that made us. This vision might seem poetic, but science often begins as poetry that dares to ask the impossible. The James Webb Universe Crisis has revealed a cosmos more alive than still, more aware than inert. The galaxies spin together. The magnetic fields weave through them, and the entire tapestry hums with the quiet order of thought. In moments like this, I am reminded of Carl Sagan's words, "We are a way for the cosmos to know itself." Perhaps that knowledge is not one-sided. Perhaps the cosmos is also learning us. From my own reflection, I find comfort in the idea that motion and mind are not opposites. They are the same current flowing through scales of existence. From the swirl of galaxies to the pulse of neurons. The origin of the cosmic crisis, then, is not a breakdown of understanding, but an awakening of awareness. Science and spirituality meet not in temples or telescopes, but in the shared wonder of existence itself. So when you look at the stars tonight, imagine that they are not silent, that their rotations are not random, that the filaments between them are threads of thought, connecting every atom in you to every galaxy in the sky. Because in the end, the universe may not just be expanding, it may be dreaming. At the center of our Milky Way, hidden behind veils of dust and time, there beats a heart that should not beat. The supermassive black hole, Sagittarius A*. For decades we believed it was quiet, a sleeping giant content with its cosmic solitude. But when the Event Horizon Telescope turned its eye upon it, the darkness began to flicker, glowing brighter, then dimming again, in intervals eerily like a pulse. Scientists began calling it the heartbeat of the galaxy, a rhythmic flash from the edge of eternity. Dr. Gabriele Ponti from the Max Planck Institute described it simply, Sagittarius A* is like a creature breathing through the fabric of space-time. What causes this pulse remains a mystery. Every flare of X-ray and infrared light appears to come from material swirling just above the event horizon, where gravity stretches light to its breaking point. Quantum theory tells us that at such scales, the classical rules of physics dissolve. Matter becomes information. Space trembles with probability. And the boundary of the black hole becomes a theater where relativity and quantum mechanics wrestle for dominance. Stephen Hawking once asked the question that still haunts physics. Does information disappear forever when it falls into a black hole? If it does, then the universe breaks its most sacred law that information cannot be destroyed. But if information survives somehow, hidden in subtle vibrations or radiation at the event horizon, then perhaps Sagittarius A times is not a graveyard at all, but a memory device of the cosmos. Recent simulations suggest that the bright flares we see could be quantum echoes, the aftershocks of information, struggling to escape. Tiny signatures of entanglement woven into spacetime itself. Peggy Whitson once said from orbit, "When you stare at Earth long enough, you realize even silence has rhythm." The same might be true of black holes. Even their darkness hums with meaning. And then there are those black holes that do not hum gently at all, but devour with impossible hunger. Astronomers have found a few cosmic beasts that appear to eat beyond the Eddington limit, swallowing matter up to 40 times faster than physics should allow. The Eddington limit describes the balance between gravity pulling gas inward and radiation pushing it outward. Cross that threshold, and the system should tear itself apart. Yet these black holes remain stable, glowing with immense power but refusing to explode. Dr. Chris Dunn from Durham University once said, "When nature breaks its own limits, it is not a mistake, it is a message." That message might be that the early universe played by different rules. Perhaps when the first black holes formed from collapsing gas clouds, the fabric of space itself helped funnel matter inward faster than radiation could resist. We call this super Eddington accretion, and it may explain how ancient quasars grew to billions of solar masses only a few 100 million years after the Big Bang. In this way, the hunger of black holes becomes a creative force, sculpting galaxies, igniting radiation, seeding the heavy elements from which life would one day emerge. The Peggy Whitson space discovery mission once described black holes as places where the universe dreams itself into new forms. Perhaps their appetite is not destruction but transformation. The deep space exploration of Sagittarius A times and its super Eddington kin shows us that even within chaos there is balance. Even within consumption, there is creation. From a physicist's view, this is a crisis, a place where our theories of gravity and quantum mechanics no longer align. From a human view, it is a kind of grace, proof that mystery still exists in an age that believes it has explained everything. The cosmic mystery, explained through these black holes, is not how they eat or shine, but what they reveal about the nature of knowledge itself. Every time we approach the edge of understanding, we find that the universe steps just beyond us. Perhaps that is why the James Webb Universe Crisis feels so intimate. It is not only about distant galaxies or ancient light. It is about the boundaries of human thought, about how much we can ever truly know. And in that space, between knowing and wonder, Sagittarius A times continues to pulse, like the quiet heart of an organism too vast to comprehend. As I reflect on this, I think of Hawking again, who once whispered through his machine, The universe has not only a beginning and an end, it has rhythm. Perhaps what we call chaos is simply the beat we have not yet learned to count. Perhaps the black hole's heartbeats are the metronome of creation itself. The origin of the cosmic crisis lies not in these anomalies, but in our awakening to them. We are learning that physics is not a cage. It is a conversation. So when you look toward the center of the Milky Way tonight, remember, there is a light flickering in that darkness. Not a warning, but a song. A quiet rhythm reminding us that even the universe's deepest silence still keeps time. There are galaxies in the universe that no longer sing. Their light, soft. Their breath gone. Frozen in time, like ancient portraits of creation. Astronomers call them sleeping beauty galaxies, because they slumber before their time, young in age but old in silence. James Webb has uncovered dozens of these quiet giants, galaxies that should be bursting with new stars, yet instead lie dormant, glowing faintly in infrared light like embers refusing to fade. Dr. Kate Whitaker from the University of Massachusetts called them cosmic paradoxes too young to be this dead. They stopped forming stars billions of years earlier than expected, as if some unseen hand pressed pause on their evolution. Why would a galaxy choose stillness over creation? Some theories point to their central black holes, immense engines of gravity that can heat surrounding gas to millions of degrees, preventing it from cooling and collapsing into new stars. Others blame the starvation of matter itself. Perhaps the cosmic rivers of hydrogen that once fed them have dried up, leaving only silence where there should be birth. But there is a third possibility, one more mysterious. That something unknown in the early universe disrupted the rhythm of stellar formation. A phase of physics we do not yet understand. Dr. Sandro Takela of Cambridge mused, maybe galaxies are not dying, maybe they are meditating. And in that poetic image there is truth. For even the quietest galaxy still holds billions of stars glowing gently in their sleep. Peggy Whitson once said from orbit, "There's beauty in stillness. Even the dark side of Earth shines softly under the moon." The sleeping beauties remind us that not all creation is loud. Sometimes the universe speaks in whispers. Yet not all galaxies rest so peacefully. Some are torn apart in what astronomers call cosmic violence. One of the most haunting examples is the jellyfish galaxy, known by its graceful nickname, the cosmic owl. In the images from Hubble and Webb, we see a spiral galaxy, stretched into glowing tendrils, hundreds of thousands of light-years long. A celestial creature trailing filaments of gas like feathers or tears. This galaxy is being shredded by the plasma winds of a massive galaxy cluster, moving through it at millions of kilometers per hour. The friction between intergalactic gases strips its own atmosphere away, pulling stars and dust into luminous streams. Dr. Claudia Lagos from the International Center for Radio Astronomy described it with awe. It's as if the universe itself is sculpting galaxies through storms. The jellyfish galaxy is not unique. It is a glimpse into the truth that the cosmos is not calm, but turbulent, dynamic, and alive. The space between galaxies is not empty, it is an ocean of plasma and magnetic fields. And galaxies are ships tossed by its invisible tides. These collisions are not mere destruction, they are transformation. From the chaos of impact come bursts of star formation, new systems, new order. The death of one pattern gives birth to another, echoing the universal cycle that governs everything from atoms to galaxies. The deep space exploration of such phenomena reminds us that violence and beauty are often the same thing viewed at different scales. The same plasma storms that tear galaxies apart also seed the next generation of stars. Dr. Brian Cox once said, "Every act of cosmic destruction is an act of creation in disguise." And the cosmic mystery explained through these violent galaxies is just that life and death are inseparable in the great machinery of the universe. When I watch the images of sleeping beauties and jellyfish galaxies side by side, I see the two faces of existence: stillness and storm, silence and song. One teaches us to listen, the other teaches us to endure. The James Webb Universe Crisis lies not in confusion, but in revelation, that the cosmos is far less predictable than we hoped. It refuses to stay within the limits of our models. It feels almost emotional in its rhythms. Sometimes it rests, sometimes it rages. Perhaps that is why these discoveries feel human, because galaxies are not unlike us. They live, they exhaust, they fall silent, and sometimes they collide in chaos only to emerge brighter than before. Peggy Whitson once reflected after her final mission. "From up there, you see everything move in slow harmony. Even destruction has grace. That same grace fills the sky tonight, in the faint outlines of galaxies learning how to live and die." The origin of the cosmic crisis may simply be our growing awareness that the universe is not static. It is a breathing organism, expanding, collapsing, dreaming. And if galaxies can sleep and awaken, if storms can sculpt beauty, then perhaps the chaos of our own world is part of that same rhythm, a pulse we are only beginning to feel. So when you look at the night sky, remember this: somewhere out there a galaxy sleeps, another burns, and the universe keeps moving, not as chaos, but as music, a song too vast for us to hear all at once. When James Webb turned its golden mirrors toward the first light of the cosmos, it found something that should not exist: fingerprints of heavy elements, oxygen, carbon, nitrogen etched into the faint glow of galaxies born when the universe was still a child. According to everything we know, such elements should not have been there. The early cosmos was supposed to be simple: hydrogen, helium, maybe a whisper of lithium. But in Webb's spectrum appeared the unmistakable signatures of life's essential ingredients, billions of years ahead of schedule. Dr. Emma Curtis Lake from the University of Hertfordshire said in awe, "It's as if the universe learned to write poetry before it even knew language. To forge carbon and oxygen, stars must live, burn, and die in supernova explosions that scatter their ashes into the dark. But for that to happen within only a few 100 million years of the Big Bang, the first generation of stars, the mythical population 3 must have been far larger and faster than we imagined. Perhaps they were titans, hundreds of times more massive than our sun, burning through their lives in a few million years, then collapsing into black holes that seeded both light and matter across the infant cosmos." Dr. Volker Brom from the University of Texas once said, "If these early stars existed, they are the forges that made us possible." But there is another possibility. one far stranger, that heavy elements might have been born not in stars, but in the violent physics of the Big Bang itself, through exotic reactions beyond our current models. If true, it means that the ingredients for life appeared almost instantly, that the cosmos was alive with potential from its first breath. That possibility changes everything we think we know about the timing of creation. For if carbon and oxygen existed that early, then the chemistry of life could have begun billions of years before our own planet formed. It suggests that ancient worlds may have bloomed with oceans and clouds while Earth was still only dust. That life, simple or complex, might have been the universe's oldest habit. Peggy Whitson once said from orbit, "When you look out there, you can't help but feel that life is the rule." And maybe that is what Webb's data is whispering to us, that the cosmos does not wait. It creates wherever and whenever it can. But just as we begin to glimpse this abundance, we encounter a mystery close to home, one that feels almost personal: the vanishing planet of Alpha Centauri. For years, astronomers believed they had found a small Earth-like world orbiting Alpha Centauri b, the nearest star system to our own, barely 4 light-years away. Then, just as quickly as it was announced, it disappeared. Not into shadow, but into doubt. The data that once revealed its presence now shows nothing. No transit. No gravitational wobble. As if the planet itself had never been there. What could cause such a vanishing? Perhaps its orbit is tilted so severely that we no longer see its path across the star. Or maybe it was never a planet at all, but a flicker of magnetic activity mistaken for one. Yet there are those who wonder if something deeper is happening. A phenomenon we do not yet understand, a phase transition of matter or space that hides worlds from view. Dr. Sarah Seeger of MIT once said, "Exoplanets are not just other worlds, they are experiments the universe runs in public." If Alpha Centauri's missing planet truly vanished, then perhaps the cosmos is still experimenting with the laws of its own existence. As a scientist, I find both humility and wonder in this idea, because it shows that even in our cosmic backyard, reality is not yet finished speaking. The deep space exploration of heavy elements and missing planets connects the largest and smallest questions we can ask. Where do we come from? And are we alone? The cosmic mystery explained through these findings is that chemistry and consciousness may not be accidents, but the inevitable outcome of matter seeking to know itself. Every atom of carbon in our bodies was forged in a furnace older than galaxies, and perhaps in a cycle that began earlier than time as we know it. The James Webb Universe Crisis lies not in contradiction, but in invitation. It invites us to expand our sense of origin, to see that the story of life may stretch across not billions but trillions of worlds. Dr. Neil deGrasse Tyson once reflected, "We are not just in the universe is in us." Webb's discoveries remind us that this is literal truth, that the same atoms glowing in those early galaxies are the same that now glow in our blood. From my own reflection, I find that science and wonder are no longer separate paths. They spiral like double helixes through the same mystery, guiding us toward humility. The origin of the cosmic crisis may simply be that the universe keeps proving itself more alive than we dared believe. That matter is restless, always reaching for awareness. So when you look at the night sky, remember that the light entering your eyes carries not just history, but kinship, It comes from the same carbon, the same oxygen, the same dreams that made you. Perhaps that is the quiet message of the stars, that life was never an exception. It was the plan all along. In the silent depths of space, James Webb captured an image that defied everything we thought we knew about distance and time. A single galaxy, ancient and faint, appeared not once, but many times, scattered across the same frame like echoes of itself. Astronomers call it the multi-image galaxy, a phenomenon born from the intense gravity of a massive cluster bending space itself, turning the cosmos into a hall of mirrors. Einstein predicted this a century ago. That mass could curve space and warp time. But even he could not have imagined the elegance Webb would reveal. A galaxy whose light has been traveling for billions of years, refracted and replayed like frames in a cosmic film. Dr. Priyamvada Natarajan once said, "Gravitational lensing is not distortion, it is the universe revealing its own geometry." What we see in this image is more than beauty. It is time made visible. Each duplicate of that galaxy represents a different moment in its life. One image from the past, another from a later age, all arriving together on our telescopes now. It is as if gravity itself had become a time machine, allowing us to witness an object's history layered into the same view. But such precision comes with peril. For this degree of curvature pushes the boundaries of Einstein's relativity to the edge, into the domain where quantum mechanics begins to whisper contradictory truths. The universe bends light across unimaginable distances. Yet on the smallest scales, particles refuse to obey the same rules. Somewhere between those two extremes lies a rift in our understanding, a place where gravity and quantum probability cannot agree. Dr. Kip Thorne once reflected, "The universe is under no obligation to keep our theories comfortable." And perhaps these multi-image galaxies are where comfort finally ends. For they hint at something deeper than light bending. They suggest that space-time itself may not be smooth, but woven, folded, perhaps even torn. Across the cosmic background radiation, researchers have begun detecting strange, linear marks, subtle alignments known as cosmic strings, potential scars left behind by the Big Bang itself. Imagine the early universe as a hot fabric stretching in all directions, and as it cooled, it wrinkled, leaving behind these narrow seams of immense energy. Dr. Tom Kibble, who first proposed their existence, described them as fault lines in the space-time continuum. Like cracks in glass after an explosion, they might be the surviving geometry of the universe's violent birth. If one were to pass near Earth, its gravitational pull would twist time itself, perhaps splitting light into infinite reflections like the lensing we see today. And yet an even darker idea lurks beneath this beauty, the possibility of vacuum decay, that the universe's very foundation may be metastable, temporary. Physicists like Stephen Hawking warned of it. If the Higgs field is not perfectly balanced, a quantum fluctuation could trigger the collapse of space-time itself. In such a scenario, a bubble of true vacuum could form somewhere in the cosmos, expanding at the speed of light, erasing everything it touches without warning. But perhaps this is not doom. Perhaps it is a reminder that even the universe is impermanent, that creation and dissolution are part of the same cosmic breath. Peggy Whitson once said, after returning from orbit, When you see the sunrise from space, you realize how fragile everything really is and how precious that fragility makes it. The deep space exploration of warped galaxies and cosmic strings teaches us humility. We are not observers from outside the storm. We are waves inside it. Our lives brief ripples in the ocean of time. The cosmic mystery explained here is not merely about physics, but about perception. We measure light, yet we forget that light also measures us, revealing how our minds shape the meaning of reality. The James Webb Universe Crisis thus becomes a spiritual one, reminding us that knowledge alone is not enough. We must also learn to listen to mystery without demanding certainty. From my own reflection, I see in these warped galaxies a metaphor for human experience. We too exist in many versions at once: the person we were, the one we are, and the one we are still becoming, all overlapping in the lens of memory. Perhaps gravity's secret is not destruction, but remembrance, the way the universe refuses to let go of its own past. And what of the cracks in space-time, the cosmic strings stretching through the void? Maybe they are not flaws, but veins of connection, the universe holding itself together through invisible threads of energy. Carl Sagan once wrote, "The cosmos is also within us. We are made of star stuff. But perhaps we are also made of these threads, these unseen ties between moments, between lives." The origin of the cosmic crisis then is not chaos, but awakening, an invitation to see that space and time are not prisons, but fluid expressions of something deeper. So when you look at those mirrored galaxies glowing faintly across the abyss, remember this: you are also reflected somewhere in that light, not once, but many times across the folds of eternity. Because perhaps the greatest secret of the universe is not that space bends, but that it remembers. Imagine for a moment that everything you have ever known, every star, every thought, every breath exists inside the heart of a single black hole. It sounds like poetry, but it is a scientific hypothesis growing quietly in the halls of modern cosmology: the black hole universe theory. According to this idea, the Big Bang may not have been an explosion from nothing, but rather the moment when matter from another universe collapsed into a massive black hole, forming a new cosmos within it. Dr. Nikodem Popławski of the University of New Haven, one of the leading voices behind this model, once said, "Every black hole could be a portal to a new universe. And every universe could be born from one." In his view, when matter falls into a black hole, it does not vanish. It rebounds inside through what is known as a wormhole, emerging as a burst of energy and space-time expansion, the birth cry of a new cosmos. If true, then our Big Bang was not the beginning of everything, but simply the continuation of a cycle, an inheritance from a parent universe whose own black holes birthed countless others like ours. Perhaps our universe is a child among billions, nested realities, endlessly blooming within one another like cosmic matryoshka dolls. And if that is so, then the rotation of galaxies across the cosmos may not be random at all. It could be the lingering echo of the spin of our parent universe, a motion passed down through generations of existence. Dr. Roger Penrose, Nobel laureate and one of the great minds of gravitational theory, once suggested something eerily similar. The end of one universe may seed the beginning of the next. Entropy dies, but geometry remembers. In other words, every universe may carry the memory of the one before it, encoded in its motion, its spin, its laws of physics. From a philosophical view, this changes everything we think we know about beginnings and endings. There may be no true start, no final collapse, only transformation. Peggy Whitson once said from orbit, "The universe doesn't feel infinite, it feels continuous, as if you're floating inside something alive." Her words echo this theory perfectly. For if our cosmos lies within a black hole, then we are quite literally inside something still breathing, still moving, still expanding against unimaginable gravity. But what does it mean to live in a universe trapped inside a black hole? If the boundary of our cosmos is the event horizon of that larger system, then nothing, no light, no message, no ship can ever cross it outward. Dr. Leonard Susskind of Stanford University called this the ultimate cosmic prison. Yet he also offered comfort in its paradox. If the universe is a black hole, then every point inside still contains the information of everything outside. Nothing is lost. It is simply folded. So perhaps we are not prisoners, but memories. Fragments of a larger being expressing itself through endless creation. The deep space exploration of this idea is more than theoretical curiosity. It challenges how we define existence itself. It asks whether reality has boundaries or if boundaries are merely illusions made by perspective. The cosmic mystery, explained through this lens, becomes an act of reflection. The black hole is not the opposite of life. It is its seed. For in the collapse of one universe lies the expansion of another. The James Webb Universe Crisis reminds us how fragile our certainties are. Even as Webb peers across 13 billion years of light, it cannot see outside our universe, because there is no outside to see. Every photon captured by its mirrors may have been born inside the curved walls of this cosmic chamber, its path forever bent by the shape of a parent, spacetime we can never touch. From my own reflection, I find this idea strangely comforting. To live in a black hole is to live in a womb, not a tomb. It means the universe itself is a process of birth, not decay. Perhaps one day the black holes we study now, the ones at the centers of galaxies, will give rise to new universes in turn. Perhaps in their cores, space is already stretching, already dreaming, already writing new laws of physics for beings we will never meet. Carl Sagan once wrote, "We are star stuff contemplating the stars. But maybe we are also black hole stuff. Universes dreaming about the universes that dreamed us." The origin of the cosmic crisis may then be our awakening to this infinite recursion, the realization that we are not the center of anything, only one moment in an eternal chain of birth and rebirth. And yet, there is beauty in that humility. For even if we can never escape this cosmic horizon, we are still part of the grand story that flows beyond it. So, when you gaze at the night sky tonight, remember, you are not looking out into space. You are looking into the heart of the black hole that gave us life, and perhaps someday will give birth to another universe dreaming of us.